Let's take a look at this question now. Now, this is one of the neatest questions I've seen. I mean, one neat question, which is that they want to test you whether or not you know whatever type of binomial expansion you want to apply, whether or not you can get to this equation or not. But the main thing is that it says to use the relation y equals to x equals to y to the power one third to show that this equation has roots alpha cube, beta cube, and gamma cube. So if I have an equation like this, y equals to x cubed, and I know that in this with this equation x, I have alpha, beta, and gamma. Whatever we get by putting x equals to y to the power one third, aren't we supposed to get roots alpha cube, beta cube, gamma cube, if we know that y equals to x cube? What we're doing here is that we, instead of just making use of what? Okay. Instead of writing down, I mean, basically, if we put a substitute in, we can change. Let's say if you have y equals to x cube, instead of having alpha, beta, gamma, we have alpha cube, beta cube, gamma cube, right? That's the way things work here. So, anyways, as a result, what I want to do is that now this is a different way to just stop writing things that when I substitute, when I make use of this expression to put things here, then I want to get this equation somehow. Then I can move on from dealing with things like that in it. So that's the way it works. So let's just show you how to do that. Now, you might just tempt yourself to substitute y equals to one third on when x equals to y to the power one third on all of these, but then you realize that you're going to get such an equation that you cannot do anything with. Next step comes obviously in your mind is to multiply with any power of x. But here's a problem. 3, 1, 0. If you multiply even a single power of x with on both sides, then you realize that this cube becomes a 4, this becomes a 2, this becomes a 1. So not all of them are odd or even. So in this case, you get here 2 odd, 1 even. In this case, you get 2 even, 1 odd. Then we have here x square multiplied with this whole thing. We get 5, 3, 2, 2 odd, 1 even. Then we have 6, 4, 3, 2 even, 1 odd, and so on. So you cannot do it in this way. So the next thing that should come in your mind is binomial expansion. So you need to multiply both sides or whatever it is with a power so that you can expand the whole thing. Now, many people will attempt to just expand many people just tend to expand something like this: x cubed minus x plus 1 whole square equal to 0. But this is not the thing you want to do. What you really want to do is you want to take at least something to the other side. So let's just say you want to take x cubed equals to x minus 1 to this side. Then the issue you have is x minus 1. Then the issue you have is that once you start square rooting both sides, then what you have to deal with is that once you square both sides, then you're going to get here x to the power 6 equals to x squared minus 2x plus 1. If you try to put y to the power 1/3 here, then you're still not going to get a perfect equation with all natural number powers or integer powers. So what you really want to do is, what if I try to put x cubed plus 1 equals to x, like this, taking this x to the other side. Now, if I whole square both sides, then I'm going to get here x to the power 6 plus 2 x cubed plus 1 equals to x squared, x squared. Now, if I still put y to the power 1/3 here, then I'm going to get y to the power 2/3, which is not going to be the case. I mean, that's not what I want. So instead, what I want to do is I want to put in x cubed plus 1 equals to x whole cube, both sides, cube both sides. So I'm going to get here x to the power 6 plus 3x cubed plus 3x plus 1. No, it is going to be x to the power 9, 3x to the power 6, 3x cubed plus 1 equals to x cubed. Then we have so on. So that's what I'm going to do here. So the first step is substituting this thing to here to there. So at first I would like to imply a statement here that according to this part, if equation in X has roots alpha, beta, and gamma, then equation in Y should have roots alpha cube, beta cube, gamma cube. I just want to make sure that I substitute when that if y equals to x cube. I just want to make sure if I substitute, if I make use of this relation, I can get this equation. So as a result, I have to write it down like this. X cube equals x cube plus 1 equals to x. So I get here cubing both sides, x to the power 9 plus 3x to the power 6 plus 3x to the power 3 plus 1 equals to x cube. So we have x to the power 9 plus 3x to the power 6 plus 2x cubed plus 1 equal to 0. X equals to y to the power 1/3. Then we have y to the power 1/3 whole to the power 9, 3 y to the power 1/3 whole to the power 6, 2 y to the power 1/3 whole cube plus 1 equal to 0. So we have y cube plus 3y squared plus 2y plus 1 equal to 0. Leads to equation above. That's the thing I want to show. Then if it says to find out the summation of the roots of this equation, which is basically alpha cube lowercase plus gamma cube. If so, I mean, I don't need to do anything else. I just have to do alpha cube plus beta cube plus gamma cube equals to, we know the summation of the roots equals to minus b by a, or the coefficient of this by that. So it's going to be minus. Then we have this one, s of minus 3, which means I need to find out s of minus 1 of s of minus 3 of x equals to s of minus 1 of y, same thing as this one. S1 of y is the same thing as S3 of x. So in this case, if we have S3 of x equals to S1 of y, which means I need to find out S minus 1. So S minus 1 is some of the things that we should be able to know, which happens to be summation of alpha cube beta cube divided by summation alpha cube beta cube gamma cube. So it means that summation of alpha cube beta cube happens to be, I mean, the summation of the pairs of product, which has to be 2, and the summation of the, and the product of the roots happens to be minus 1. So answer is minus 2. I think 1 mark is for FT, or follow through by error, after error. Show that S6 equals to 5 and find the value of S9. So S6 of X is the same as S2 of Y. Basically, we have alpha cube whole square, beta cube whole square, gamma cube whole square being added together, which is the same thing as alpha to the power 6, beta to the power 6, gamma to the power 6. So this is how it looks like. Now, because it is S6 or basically S2, we know that there is another thing we must remember. S2 equals to summation of alpha cube whole square. No, actually it is summation alpha whole square, summation alpha cube whole square minus 2 times summation of alpha cube beta cube. That's the one I believe it should be. Yeah, it should be the one. So summation of alpha cube whole square happens to be minus 3 whole square minus 2 summation alpha cube beta cube, which happens to be 2. So 9 minus 4 equals to 5. Okay, we are good. Then we have S9. For S9, S9 of x is the same thing as S3 of y. And S9 of x, because we have here the roots to the power n. So S1 means alpha plus beta plus gamma, which is the same as S1 of x. S2 being alpha square, beta square, gamma square, which is the same as S2 of y, and so on. So I mean, S2 of x in it. So this is the way this thing works. Okay. Then for S9 of x, it's the same as S3 of y, as we have seen already earlier. So what I have here is, look, let's just go back to this equation for the first, I mean, for the time being. So in this case, if I rewrite this whole thing in terms of recurrence notation, basically we are just trying to, replace the y with the roots of this equation. So we have alpha cube whole cube 3 alpha, let's just say alpha cube whole cube 3 alpha cube whole square 2 alpha cube plus 1 equal to 0. Basically, this is root A. I'll just call alpha cube as A, beta cube as B, gamma cube as C, just for the time being, just for reference. This is A, this is A. And then we do the same thing with B. Let me see. What you notice is that we get 3A cube plus 3B cube plus 3C cube and so on, plus 1 plus 1 plus 1. So this is the same as 3 times A cube plus B cube plus C cube plus the same thing here, 3, let's say 3 times A square plus B square plus C square plus dot 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 plus 1 plus 1 plus 1. Now, isn't this the same as the summation of the roots whole cubed, which is the same as S3 in this case? So 3 S3 plus 3s2 plus 2s1 plus 3. We are adding the constants together. So we know s1, we know s2, we know s3. S2 is so S1 is basically minus b by a. So it's going to be minus 3. So 3 S3 plus 3 S2 is 5. 2 minus 3 plus 3 equal to 0. 3s3 equals to 6 minus 3 minus 15. So we have 3s3 equals to minus 12. S3 equals to minus 4. Let me verify my answers from the mark scheme. Actually, it is minus 12. Oh yeah, actually, I'm supposed to find out S9 here. So, um, yeah, it's not 3s3. Actually, accidentally I wrote 3. It's supposed to be just 1. Silly mistake. So it is y cube, not 3y cube. If it was 3y cube, then it would have been that. So this is my answer. You need to be careful about that there. Only add the numbers from here, only multiply when you have constants. If you have coefficients, leave the if you have variables, leave their coefficients as is. All right. So that's that. Yeah, I mean the question explaining it was a bit lengthy, but it was pretty straightforward.